Here is our theorem from the previous video about the slope of the tangent line for parametrically defined curves. Let's put this to work. So our parametrically defined curve is C of t is t squared plus 1, t cubed minus 4t. So two tasks here. Let's find the equation of the tangent line at t is equal to 3. And let's also find points when the tangent line is horizontal. So for the first part, find the equation of a tangent line. We know we need the slope, and the slope is going to be just from this. So let's calculate out dy dt and dx dt separately. So dx dt is 2t, dy dt is going to be 3t squared minus 4. So dy dx is simply the ratio of these two. 3t squared minus 4 divided by 2t. So this is our dy dx, because dy dx is dy dt divided by dx dt. Okay, so find the equation of the tangent line when t is equal to 3. So note right here that we have dy dx, so it's written in terms of t. That's kind of convenient for us. So when t is equal to 3, dy dx at t is equal to 3 is 3 times 3 squared minus 4 divided by 2 times 3. And crunch out the arithmetic, 23 over 6. So to find the equation of a tangent line, we need two things. We need a slope and we need a point. Well, here is our slope, but we still need our point. So to find the point, what are we going to do? Well, we have t is equal to 3. Let's plug in 3 up here into c of t. So c of 3 is equal to 3 squared plus 1, 3 cubed minus 4 times 3. So that's going to be 10, and 27 minus 12 is 15. So now we're ready to write down an answer. Our slope here is 25 over 3. Our point is x is 10, y is 15. So point slope form, our equation is y minus 15 is equal to 23 over 6 times x minus 10. Okay, so this is the first part of the problem. Now let's find points when our tangent line is horizontal. And so to do that, how do we know we have a horizontal tangent line? That's when our derivative is equal to 0. So dy dx, from the previous slide, I'm just recopying this, 3t squared minus 4 divided by 2t. And we want to set this equal to 0. And what do we end up with here? We end up with, we of course only care about when the numerator is equal to 0. So 3t squared minus 4 is equal to 0. 3t squared is equal to 4. T squared is equal to 4/3. T is equal to plus or minus the square root of 4/3. And that is plus or minus 2 divided by square root 3. Okay, so note here that 2t is not 0 when at these values, so everything is on the up and up here. Okay, so now we have to plug in. So we have to find c of 2 over square root 3 and c of minus 2 over square root 3. So plug these in once again into our parametric equation here. And so we have 2 over square root 3 squared plus 1, comma, 2 over square root 3 cubed minus 4 times 2 over square root 3. And minus 2 over square root 3 squared plus 1, comma, minus 2 over square root 3 cubed minus 4 times minus 2 over square root 3. And when you crunch this out, crunch, 7/3 and 16 over 3 square root 3. Sorry, that should be a minus 16 over 3 square root 3. And this one would be 7/3 and plus 16 over 3 square root 3. Okay, this problem I actually stole straight from the textbook, so let me just show off here the picture that they have here. So as t is increasing, we go up here around the loop and back up this way. We found the tangent line right here at t is equal to 3, and see that there are 2 places here where the tangent line appears to be horizontal, and those are the 2 points that we just found. 7/3 minus 16 square root 3 over 3, minus 16 over 3 root 3, 7/3 plus 16 over 3 root 3. And so those are those 2 points, and you can even see they appear to have the same x value, which is confirmed by our calculations. Okay, so that is finding slopes of tangent lines, an example of that. So here is our second pre-class problem for the section. So please find the equation of the tangent line to this curve. X is 3t squared plus 1, and y is, let me write that a little bit more clearly, 1/2 t squared minus t when t is equal to plus 1.